Hey, Clint.
Hello, Ken.
I figured we should probably step through the Kubernetes quick start, kind of show how it works.
Sounds exciting.
So OpenZiti.io has docs, and if you go there and drill down to quick starts, network, Kubernetes, there it is. Uses Minikube, and although there is a script, I'm going to fly through the manual steps, kind of explain just a little bit and expose how the script works. This reflects the script. It does all the same stuff and gets the same result. You got your prerequisites there. Starts with DNS. You ready to go?
I'm so ready.
All right. I'm going to zoom this a little bit. Does that look good?
Yep.
All right. First, we need a Minikube. I'm going to copy paste all these commands.
Now, hopefully
Boom.
everything that you're going to do, I could just copy and paste, right? No configuration changes, no updates. It'll just pop, pop.
Yes.
Oh, but
I mean, it's rare you can say that.
okay, just a yes. All right.
You just got to be in
Straight up.
Linux, and you have to
Yes,
have that
that's
stuff
important.
installed at the top.
Ah, yes, the
Yeah.
prerequisites.
I've already installed that stuff, so just to save time. So we're going to start up a Minikube, which is a single
Okay,
node Kubernetes cluster using Docker.
it's
And so you got
running.
to have Docker for that. And then we're going to use as root, we're going to append to our Etsy host database file a list of basically like DNS records,
Neat.
MiniZiti
Cool.
controller, MiniZiti router.
Okay, so
And
this is everything local Minikube Kubernetes example. What are the
right,
three greater thans or less thans do?
it's a bashism that means send the string to standard in. So T takes standard in
I see. So this is so
and
you can sudo it.
appends.
I gotcha.
Yeah.
And so if you run this multiple times, you'll just end up with multiple of these lines.
Yeah, this very last line is the output from T. See what I've got highlighted on the left there?
Yeah, but my point is if you run it multiple times, you get multiple entries in your hosts file, and you'll want to clean those up someday.
That's
Probably.
true. And if the cleanup steps at the end do not include that, they should,
Yeah,
because you can't, if you like this IP address might change if you have more than
sure.
one Minikube.
Yep.
Okay.
So that's
So
important.
this is correct for mine, because that's the IP address that Minikube gave us for our cluster. All right. So all I have to do is click on manual steps here to flip over from the script tab. And
So I could run it all as a script if I wanted to.
you could, yeah. You
All
just
right.
need to
And
download and run it like this.
all right. And I presumably this bash file runs the same or pretty close to the same commands that we're going to see here.
Yeah, that's right.
All right. All right.
It
So I'd
does.
probably use the script. So if you're not interested in fumbling around with this, you could use the script too.
Yeah. I probably didn't need to run that, but I ran it again since it was there just in case it causes a problem. When you're doing this it is necessary to do this if you are coming from Windows or Mac OS, but it's not necessarily on Linux. It's just a
We've already
documentation glitch.
we've
Yeah.
already stated that we need to be on Linux.
For this example, you're on Linux. It does simplify the networking steps. There's a reason why we're on Linux. Okay, so here's a note about switching between different profiles if you end up doing that, but it's not necessary. So we can run the cluster info command just to make sure our kube config is good. There's that IP again, the one from Minikube. And we can see that our cluster is now online. Good. There's a little bit of explanation about that. Now we need a couple of Minikube add-ons. This is just a little easy button for installing these Helm charts that are available from Minikube. Minikube is from the Kubernetes project, so they're giving us the ingress controller from the Kubernetes project as well, called ingress nginx. Now, there's an important thing to know about using OpenZiti anywhere, but especially in Kubernetes, where there's almost always a load balancer involved. OpenZiti itself uses TLS, specifically MTLS. So it's important that that TLS handshake makes it to OpenZiti itself. You can't terminate TLS on behalf of OpenZiti in almost all cases. So we're going to configure our ingress controller for SSL pass-through by adding this argument to the startup options. I'm going to do that by copy and pasting these commands. We're going to patch the deployment. That'll trigger a rolling restart of the pods for the ingress controller. And then we'll just wait to make sure that that is all up and happy. Paste, run. And since I'm in Z shell, this is just an error since I pasted these comments as well. But we're waiting for that. And now on the bottom pane, I'm going to open another visual view of the pods using K9S. You don't have to do this, but it's nice just to be able to see everything that's happening. I've sorted the list of pods by how old they are, this age column. Okay, moving right along. Our conditions were met, so we're good on that patch operation. Now we're going to install the ZT controller. So we need to basically install these prerequisites, cert manager and trust manager. These are custom resource definitions that add APIs to Kubernetes that do not come with Kubernetes. You can do that just by pasting the commands. And there you can see all the CRDs were downloaded and applied to the Kube API. And that gives us new resources like issuer, bundle, and certificate that are used by the OpenZiti controller. Now, I already have this repo added, so I'm not going to run that command. It'll just generate an error, but no problem. Now, install the controller chart. I'm just going to paste this verbatim. These are some input values that I'll explain while it is installing. What are these things doing? We're going to tell Helm to install unless already installed with this option. We're going to create the namespace MiniZiti unless it already exists. Just happen to be using the same name as the Minikube profile. And this is the chart reference. This is the Helm chart reference from the repo that we just added up above. This is our Helm release name, ZT controller. And then as you can see, that's used to construct the pod names and things like that. Now these set options are Helm input values, Helm chart input values. These basically represent non-defaults, things that we need to configure for our deployment.
And don't change any of these.
I
If you're
wouldn't
following this video,
right,
don't
right.
change any of these. Just copy
You
and
don't need to
paste it
change any of these.
and let it
That's
go.
right.
All right.
So that did complete, and we can run this command. It should have condition met right away. That would have just we could have run that right away, and it would wait until the ZT. Oh, it's waiting for the ZT controller to initialize. You can see right here, the ZT controller pod is not yet ready, but it will be soon. So this will wait up to 2 minutes, well, 4 minutes for that deployment to have condition available true. All right, so did we explain all the different options? Basically, ZT needs an advertised host, so that's the correct value that we chose above when we created our host record. Well, we got to wait for this to finish, but we can go ahead and
start explaining. Let's start explaining it.
Yep. So here's cluster DNS. We need for this name, MiniZiti controller, MiniZiti internal, to be resolvable inside of our cluster. But it's not going to be resolvable by default because the cluster comes with its own DNS. So we need to configure that DNS to know how to look up that name. Now, this IP address is our Minikube IP. And a little earlier, we installed a name server in our cluster when we installed this add-on, Ingress DNS. This makes our ingresses resolvable as DNS records. So we need to tell the DNS that comes with our cluster to use that name server to look up those names. Does that part make sense?
Yeah, my expectation is core DNS here is basically operating like an Etsy hosts file for Kubernetes.
That's right, because any pods inside of our cluster don't have access to our Etsy host file, which we modified. So they have their own DNS, and we have to tell that DNS to
just like we did for
just
like we did for our operating system. We need to do that for Kubernetes.
So let's see. If I set Visual Nano, then I think this will reflect what most people will see if I run the edit command. Nope. Try that again. editor nano. There we go. This is what it'll look like for almost everybody. We're in nano editing our config map named core DNS. Now we need to add this entry. So I'm going to put that on my clipboard. And using this example right here, we can see what it's supposed to look like. We want this to be down at the bottom with the same indentation as the thing above it. So I've already added the spaces actually that you need right here. So let's try, can I mouse in here? Nope, I got to use the arrow keys. So I'll just arrow down, add a line, paste it. There we go. I think we're good. So to exit out of nano, Control X, save yes, file name cool, done. That has edited our config map, and it does not automatically trigger a rollout. So we need to delete the pod. We'll use a pod selector to do that. That'll cause Kubernetes to redeploy it. There we go. Now we can see that core DNS pod is fresh and new, and it's using the new core file. Now let's run a quick test to make sure that our DNS inside the cluster is actually working. So to do that, we'll do a one-shot deployment of BusyBox, and all it's going to do is run NSLookup inside the cluster in that pod against that domain name, make sure it resolves, and it does. And that pod has now been deleted automatically because it was a one-shot deployment. Now let's install the router. We need to log into OpenZiti. We're going to do that by getting the secret from Kubernetes and decoding it and piping that over to our login command. Does this part make sense, Clint?
It looks like I'm going to be fetching some sort of secret from Kubernetes using kubectl, and then I'm going to use xargs, and then that's going to go into my login. It all makes sense.
Yeah.
Yep.
See how it's two commands, one that pipes into the next. We could put it on our clipboard and then run.
No, you just copy and you paste that command.
We'll do it just like that.
Speed run this, remember?
Now we are logged in with Ziti.
Perfect.
So we can say Ziti list identities or whatever, and we can see stuff. Okay. So we're going to create a router by pasting the next command. That's going to give us this output file. It's an edge router JWT, edge router enrollment token. We've assigned role attribute public routers. And now we can go ahead and deploy the router and wait for that router deployment to be ready. CD router does not exist. Deploying now, CD router, container creating, CD router running, waiting for ready state. And then we'll run the list edge routers command just to make sure that router is showing online in Ziti. It is, and it has the public routers attribute that we assigned. This is what it should look like, and it does. Let's go ahead and put that admin password on our clipboard so we can log into the console. This is just to assist with visualizing what's happening. That's the wrong place. I think I used HTTP instead of S. There we go. Advanced. So note we need to update the instructions to say HTTPS. And here's the clipboard, password, paste, enter. Now we're logged into the console. We can see our identities and our routers and our policies, which I don't have any policies yet. Okay. What's the next step in the instructions? Create OpenZiti identities and services. This is a list of ZDCLI commands. We're going to create an identity, a config for a service, create the config, create the service with those configs, create the service policies, edge router policies.
Yeah,
everything.
That's a lot of stuff.
Something went wrong with my paste.
Did the identity?
Let's make sure all those actually succeeded because there was something weird about the paste.
Yeah, you got a 200 right there, but yeah, see that you got like a Control C or some command character that was at the beginning of it.
So we have to go back and make sure we didn't create Minikube client like we should have. Maybe I can just run everything again. I must have hit a button that added
Yeah,
some
I
corruption in
often
there.
have this when I control V and then hit an arrow key or something along those lines.
So we know we need the identity for MiniZD client. Do we have MiniZD? HTTP bin host is already created, so we can delete that one.
You don't have a delete all the things, do you? Just delete them
Say
all and then
again.
run them. You don't have a delete all script?
No.
All right.
Create config. So unfortunately, like this
The
is like
one thing you have to look
troubleshooting. I
out
don't
for is
really want to do. Yeah.
the policies. Just look at the policies because that probably couldn't link the identity. No, go into the Zach on the right. It's down the service policies.
Service
And just
policies.
make
We
sure
have a bind and dial policy already,
and
so
they're both
those are
linked.
good.
So that's cool. It worked out.
And service router policy is good. Router policy is good. So we don't need those guys. And we already did the enroll on HTTP bin host. So this is really the only one that didn't run. Oh yeah, by the way, you don't have to keep saying device anymore. This is old. So that's a second note to remove the identity type from the instructions. Okay, so we did all that. Those are the ZD commands, and now we have a ZD service set up, but we need to actually use it. So that identity that we just created and enrolled is in this file name. We're going to install another chart, HTTP bin, and that is going to use that identity. What it's done is deploy a Go SDK app hosting a service that is HTTP bin. Now, the other identity, which is in this file, is just sitting there waiting to be enrolled. And we need to add it to our tunneler. So this doesn't say how to add it to your tunneler, but we're using Linux, so we need to follow the Linux instructions for ZDH tunnel. And that looks like ZDH tunnel add JWT, I think. We'll give it the contents of that JWT file. And then we have to say,
Why are you typing?
Because, like I said, we don't have pastable instructions for all operating systems. We just have a link to the instructions for all operating systems.
Does that instructions have a copy? Can I copy from that?
Yep, it does.
See,
it does.
Perfect. That's what I would do.
You'd have to go over here to, why don't we just show this? Go to Linux, go to, well, all of the instructions go to say you have to add an identity, and they all have the same information right here. It's that add command I just ran with JWT and identity options.
Perfect.
So it's there.
Thank you.
There for all operating systems. But after you add the identity to your tunneler, then you can get to this service that is provided by ZD. So this is a fictitious domain name as far as global DNS is concerned, but it's real on this device. And you see how the IP is 164.31. Now we can send an HTTP request to that URL and parse out the response. If we don't parse it out, it looks like this. We can send whatever we want and talk to that service. It's also available as a web page here. If I copy that link, go there in my web browser, we can see HTTP bin, because this entire computer has been configured by ZDH tunnel to talk to that service. And if we look at the logs coming from that pod, then we can see the connections coming through. If I hit refresh here, refresh, we see status 200 for that GET request against the / path. Okay, so we're talking to our demo service, and we've already explored the console a little bit. That's the end of the speed run, Clint. The next steps, if we were to do more, would have to do with publishing more stuff, maybe by updating that router with new services, or going on
Oh,
to...
we're going through this quick start, so there
cleanup.
is no more stuff.
That is it. Okay.
Boom, mic drop. 20 minutes
So,
almost on the money.
well, we verified here. We were worried that we didn't have a cleanup step for that, but we do. So I'll go ahead and run that
Nice.
and delete the cluster. Now we should see K9S on the bottom here get unhappy because it's going to lose its connection. But our cluster is now cleaned up. It doesn't exist. We're done. That is everything.
How exciting. Cool.